In this video I'll look at binomial expansions. So when we have the term a plus b, that is a binomial as it has two terms. Any expression of the form a plus b to the power of n is called a power of a binomial. So how do we expand a plus b power n? So we'll look at expanding three examples here. First up, a plus b to the power of 1, which quite simply will remain just a plus b. Now a plus b squared, we've seen before, a perfect square, you square the first term, so you get a squared, you square the last term, you get plus b squared, and you'll get a third term, which is going to be the product of a and b doubled, so two lots of a times by b. Now to work out a plus b cubed, let's work out a plus b times by a plus b squared. So replace a plus b squared by a squared plus 2ab plus b squared, and then expand the a through the second bracket followed by the b through the second bracket. So we end up with a cubed plus two lots of a squared b plus an a times b squared. Now multiply the b through that second bracket, and we end up with that expansion there. Now let's collect like terms, and so we end up with a cubed plus, now we've got an a squared b there and a squared b there, so there's three lots of a squared b. We have an ab squared here, another ab squared there, so there's three of those, and we end up with just the final term, the b cubed. So a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. Now if we look at those two expansions, a plus b squared, a plus b cubed, there is a pattern to it. For a plus b squared here, we can see we've got the first term has a squared, the next term has a power 1, and the third term is a power 0. For the a plus b cubed expansion, we see a cubed, a squared, a power 1, and a power 0. So each term begins with an a at the maximum power and then reduces by 1 each time till we end up with power 0. And at the same time, if we consider the b term, so our b term when squared, we have no b term initially, that's b power 0, then b power 1, then b power 2. And likewise for the cubic expansion, just looking at the b terms, we have b power 0 here, b power 1, b power 2, and b power 3. So each term has the product of a and b, and the powers in each case, one will start at the maximum power, then reduce, one will start at the minimum power and increase. So if I were to have something like a plus b to the power of 4, then I expect I'm going to have an a power 4 times by b power 0, then add to that an a power 3, b power 1, then there'll be a squared, b squared, an a power 1, b cubed, and finally a power 0 and b power 4. But what about these numbers? We've got 3, 3, we've got a 2 there, and it appears to be 1s elsewhere. How do I work out what the numbers are in here? Well, the numbers come from Pascal's triangle, which is what we have here. So in each of these rows, the two numbers above will add to make the number beneath and in between. So 1 plus 3 makes 4, 3 plus 3 makes 6, 3 plus 1 makes 4. So those numbers there are the coefficients. So if we look at the expansion of a plus b squared, we look at the second row of Pascal's triangle here, and we've got the 1, the 2, and the 1 there. If we then look at the third bar Pascal's triangle here, and then the a plus b cubed expansion, we have 1, 3, 3 and 1, which come from those numbers there. So now if we go back and look at a plus b to the power of 4, then we can use the fourth row of Pascal's triangle, which is the last row here. We have 1, 4, 6, 4 and 1. So we have 1 here, 4, 6, 4 and 1 there. And that would be the expanded form of a plus b to the power of 4. So let's expand x plus 2 cubed using that particular technique. So the third bar Pascal's triangle is 1, 3, 3 and 1. And then each term will have an x term. So we begin with x to the biggest power, 3, then x squared, then x power 1, then x power 0, which is 1. Then we look at the 2 and we multiply the x and the 2 together. The 2 begins here as power 0, so we can leave that out. Then we have multiplied by 2 power 1, 2 power 2, and then 2 power 3. And then throw your plus symbols in between those 4 terms. And we can simplify that to get x cubed plus 6x squared plus 4 times 3 is 12x, and then plus 2 cubed is 8. So that is x plus 2 to the power of 3. Alright, so x take 4 to the power of 3. Once again, we have the third bar Pascal's triangle. So 1, 3, 3 and 1. Begin with x to the power of 3, then x squared, etc. And then multiply each term by negative 4 raised to varying powers. So negative 4 power 0 here is 1. We can leave that out. And then we multiply by negative 4 to the power of 1. Put it in brackets. Then negative 4 squared. And then multiply here by negative 4 cubed. And now put plus symbols in between. Now simplifying that, we end up with x cubed. Now over here we've got negative 4 times by 3 makes negative 12x squared. Over here we're going to have positive 16 times 3, so 48x. And the final term will be negative 4 cubed, which is going to be negative 64. Now notice here that when we have the difference here in my binomial expansion, then my terms here alternate. I've got a positive here, then negative, positive, negative. And that should be the pattern when we have a negative in our binomial expansion. So let's do an expansion to the power of 4. So we need to look at the fourth row of Pascal's triangle, and that is this row here with the 1, 4, 6, 4, 1 as the coefficients. So 1, 4, 6, 4 and 1. Notice that when we have power of 4 here, we in fact have 5 terms in our expansion. There's always one more term in the expanded form than the power. So now each term has an x, beginning power 4, then power 3, 2, 1, and finally power 0. At the same time, negative 2 begins at power 0, then power 1, power 2, power 3, and power 4. Put plus symbols in between. And now simplify. So we have x power 4 here. Over here we're going to have negative 2 times by 4 is negative 8. Over here we're going to have a positive 4 times 6 is 24 to the x squared. We're going to have negative 8 times by 4 and x, and negative 2 to the power of 4 will be positive 16. And once again, negative term here, and these terms here are alternating positive and negative. And my final expansion, once again power 4, so I'm going to have those 5 coefficients at the start of each of my terms. So we've got 1 times by 2x to the power of 4, and then multiplied by 1 to the power of 0, plus 4 2x to the power of 3 times by 1 to the power of 3. Now that 1 there, raised to any power, means when I put it in here, it's always going to be 1. So I can actually disregard that 1. Next term will be plus 6 2x to the power of 2, forget the 1, plus 4 2x to the power of 1, and then plus 1 times by 1 to the power of 4, which is just going to be 1. And simplifying all that, and we end up with these 5 terms in our expanded form. So that is using binomial expansion.